Hey guys, welcome back. So today I wanted to do a comprehensive guide on calibrating your printer in Clipper. So we're going to be going through Z offset, E-step, PID tuning, and also retraction calibration. So hopefully you enjoy and hopefully I can earn your subscription today.
Alright, so to start off with, we are going to do the paper test and make sure that our Z offset is set properly. So to start off, we're going to home all of our axes. So make sure that there's nothing on the end of your nozzle, like a piece of filament or anything. Make sure it's clean, or it's going to skew your results when you end up doing the paper test. Alright, so once this homes, we're going to run a command for the Eddy that is up on the screen in the console there. If you're using a bltouch, or, well, I only really know the bltouch, so I can only really speak to that. You're going to want to do probe calibrate, and after that everything's going to be the same, just the command is different. So I'll put both of them in the description, and if you have any questions, just let me know and I'll answer. Alright, so we're going to start the calibration and start doing the paper test. Now it's going to home again. And then we have the dialog box. We're going to get our piece of paper, put it underneath, and I'm going to move the camera a little bit so you can see underneath. Alright, so there you go. Alright, I'm going to bring the bed down now. 1 millimeter at a time because we're still really high. Alright, we're a bit closer. I'm going to start bringing it down by 0.1. And I'm just going by eye. I can still see a little bit of gap underneath. But now I'm going to start just slowly moving it until I start feeling resistance. Still nothing. Just bringing it down by 0.1, and now it's gripping it. See, like, I can't really push it through like I could before. But if I really try, I think I can. Yeah, so see, I can still, with some resistance, push it through. So that's what I want to see. So I like that. I'm going to accept, and then it's going to do a little probe. And once that's done, I'm going to print the test print that I made. I'll also have a link to that for printables in the description. And I'll show you that once that's done. So that's what our first layer looks like there. Looks pretty good. It's a little bit low on this side, or sorry, a little bit high on this side. And, oh god. And a little bit low on this side. I think it's the bed though, and I don't think my bed can compensate well enough. It only really shows up on larger prints. Like if you just doing like a benchy or something like that, it doesn't really show up, and normally I don't print 150 by 150, so I think it turned out really well. Just a little bit of artifacting.
All right, quick shout out for PCB Way, sponsoring today's video. If you're looking for affordable, high quality PCB prototyping, they are definitely the way to go. They offer custom PCBs starting at just $5. They also do CNC machining, 3D printing, and even assembly as well. So yeah, if you want fast, reliable PCBs and assembly, 3D printing, and CNCing, check out the link in the description. All right, so we are going to do E-steps now. So for E-steps, we're going to want to go to our printer configuration, head down to our stepper extruder. And then under Extruder, there's a section rotation distance. Let's see if I can make this a little bigger. And there we go. So under Extruder, there is rotation distance. And this is my default. I'm going to copy 33.5. So this is my old one that it was already calibrated to. So this is what we should get. So you're going to want to come over to this website here, and you're going to put in the 33.50, and then the actual is going to be what we get, and the requested is going to be our 50. Come back here, and we're going to close out of that. And because, just to make things easier, we're just going to heat up the nozzle to 180 and extrude it like that. We're not actually going to be pushing any filament through the nozzle because we want a baseline of what the extruder can push without any back pressure from the nozzle. So I'm going to head over to the printer and I'll start showing you what we need to do.
All right, now that we're up at temp, we're going to set up our extruder. So I've moved this completely out of the way, and what you're going to want to do is you're going to want to take off the Bowden coupler, and then cut your filament flush with the with this piece here, because we're going to measure from the end of the filament back to that. So on the in clipper, we're going to look at 50 millimeters here and 5 millimeters per second, and we're going to hit extrude. And it's going to start extruding really slowly. And there we go. So with a ruler, I'm going to grab the end and put it next to the 0, and we're looking at 35. So 35 millimeters is what was extruded. So we're going to go back to the computer and plug it into the calculator and get our new rotation distance back. And then we'll come back here and test that it gives us 50 millimeters extruded.
All right, so you're going to want to come up to this website. I'll have it linked in the description. So what you're going to want to do is put the 33.50 that we had before, our actual extrude, which was 35 millimeters, and the requested extrude distance, which was 50. So once we hit calculate, we're going to get a distance of 23.45 for our rotation distance. So then we'll come back to our printer configuration and head down to the extruder driver. And I'm going to also just put this here so I can remember. So 23.45. So pretty close. Quickly head back to the dashboard so the extruder doesn't cool down too much. Quick. It's a Revo. Doesn't really matter, but try not to cycle it too much. All right, so now that we're back up at temp, we'll go back over to the printer and we'll confirm that our 50 millimeters, our 50 millimeters a second, or 50 millimeter filament length, and our feed rate of 5 millimeters per second. So, see you back over the printer.
All right, so back over the printer now. What we're gonna do is we're gonna cut this flush again. And we're just going to extrude another 50 millimeters. And this time it should be 50 millimeters. It's definitely significantly longer. So 0, and it is right on the 5. Kind of hard to tell, but it's right on the dash. Maybe here at that angle. 1, 2, 3, 4, 5. Yeah. So right on the 5. So that's perfect for our E-steps. Alright, so we're going to take a look at retraction now. So this was the first one that I printed. Ooh, let me pick her up. So this one was 0.5, 40 millimeters a second at 210 degrees. And it was not good at all. Stringing all the way around. Yeah, not good. So then we changed the settings to 1 millimeter, 40, 200. And yeah, not much better. So then we went to 1, 40, 210. Started looking a bit better actually. I mean, compared to the crap that we had before. So we're going to be changing settings again. Now we're at 125, 40, 200. Still stringing, still bad. This is when we start to get our improvements though. So this is when we went to 2, 40, 200. And a lot of the stringing is gone, just a little bit on the back there. So then, same result here with 25, 40, 200. Minor stringing, really not much to clean up. These two are really like where I want to have retraction worst case. So this one is 275, 40, 200. And this one's what I'm printing at now. Minor stringing, I just blow with a heat gun and it's perfectly fine. Alright, so PLA temp tower. So a lot of these are like fine to print with. I'd say 195 up to 215 is completely fine within this range. This was printed using that one. So the retraction settings are the same from that. And yeah, I think 200, 215 is a good range. I think I'll probably be printing at 200 from now on. So we'll move on to the PETG. So this first one here is 2.5 millimeters, 35 millimeters a second at 235. So really not bad, but except for the tops. The tops are really not great. I'll try and clean that up a little bit, and we got this one, which is slightly better compared. I don't think I have this one dialed in well enough yet. I think there's a lot more that I could do, but I ended up being happy with 25 or 2.5 millimeters, 40 millimeters a second at 245 C, and that top blob right there is just from the extruder nozzle, and yeah, this one is definitely the best. So then we went ahead and printed another temp tower using that one, and the bridging was pretty terrible, except for 240 and 235. Bridging was pretty good. 245 was also alright, but I'd say 240 was better for the bridging. Let's see if I can get that in frame a little better. A little bit more droop on the 240, or 245, which is that one. This PETG is pretty shiny, unfortunately. Alright, so I'll have the stuff in the description on these models for you guys to use. And if you have any questions on tuning, again, leave it in the comments and I'll reply to those.
All right, so now the easiest one on the list are PID tuning. That's my cat scurrying away. Goof. All right, so the command that you're gonna need is PID underscore calibrate heater equals extruder, and then your target, which I'm gonna change because my printer goes up to 300. I'm gonna PID tune for 280. So what you're gonna do is type in that command, make sure your extruder is gonna go up to the temperature that you want to PID tune. I mean, if you're only ever going to print PLA, you might as well just 225. PID tune 225, you should be good no matter what. So I'm going to go ahead and hit enter. We're going to see here, I'll zoom in just a little bit. We're going up to 280 now. And once it gets to 280, it's going to drop down to 275, up to 280, and do that 10 times and record the values. So I'll spare you the wait, and I'll show you what it looks like after, and everything should work out. As you can see, we're now at the top. We went from 280 down to 275, and it's switching back and forth. The Revo hot end that I have on here is amazing at heating up and cooling down. So this usually only takes a couple minutes. The bed now, once we finish with this, will take, it takes forever, like 10 minutes, 15 minutes. It's so slow to cool down. So we're just going to finish up that, and we'll come back when we're doing bed. So we're done with the hot end, and we're going to go save config. It's going to restart. Wait for the printer to be ready. And we're going to come back down to console here. We're going to hit the up arrow key. We're going to delete all this. And we're going to go heater underscore bed. Pretty sure that's what it is. And we're going to go target equals. And I'm going to do 80 because that's about the limit for an Ender 3 bed. So I'm going to go hit enter and scroll up a little bit. And the heater bed is warming up. So like I said, this one will take a long time. I won't let you guys watch that one. It's the same as the extruder, just significantly longer. We'll come back once that's done, save the config, and we'll talk about it then. All right, so our heater bed PID is now done. So we will save config, restart printer, and then we're done. So that was what you need to get started with tuning your printer. There are a few more in-depth tuning items that we'll need to cover, like for instance VREF for your drivers and skew correction if that's an issue. Um, I'm gonna try and simulate that on my printer so that I can get a skewed print and then we can fix it. I'm not sure how I'm going to achieve that yet, so that's still in the back of my mind. But yeah, that's it for the video. I hope this was helpful, and I hope I earned your subscription today. And again, I'd like to thank PCBWay for sponsoring this video. And if you need any of their stuff, check the link below, and they'll definitely be able to help you out. All right, take it easy, guys.